Okay, hello everybody, and here we are again going to talk about transformer ratios today and how to work out voltages and currents in the primary and the secondary of a transformer. Here's our little transformer model from yesterday, and as you can see I've got a coil on the primary and that actually says 500 turns. I don't know whether you can see that clearly. On the secondary I'll now slip over a coil there, and that's got 10 turns on it. So there we have a typical transformer with a primary and a secondary. And if an alternating voltage is put on this primary, an alternating voltage will appear on this secondary. But it depends on how many turns of copper are on the primary and how many turns are on the secondary. So what we need to do now is to be able to work out primary and secondary voltages and currents, and that's done using the transformer turns formula, which is V primary over V secondary equals N primary over N secondary equals I secondary over I primary. Now this formula is used usually in pairs, so you either would use those two, or those two, or those two. So you normally only have one equals another. You don't need generally to use all three at any one time. Now when you get transformer problems, it's a good idea to draw a little diagram of a primary coil, a secondary coil, there's your core, and we have a voltage on the primary. Let's say that's equal to 230 volts. We have a number of turns on the primary. Let's say that's 200 turns. And then we have the required voltage on the other side. Let's say that V secondary equals 230 volts. I'm trying to find N secondary. So that's what I'm trying to find. I know the voltage in. Sorry, the voltage out. Let's change that again. Let's say I want 50 volts out. I have 50 volts out, 230 volts in, 50 volts out, 200 turns in. What are the turns coming out? Actually, that mistake I made there. If that was 230 volts out, the number of turns on the secondary would be exactly the same as the ones on the primary, because that would be 1 to 1. Right, so I've got volts in and turns in. I've got the volts out, and I want to know the turns out. So the formula I'm going to use is this pair here. So I'll write that down. Vp over Vs equals Np over Ns. And then you substitute the figures. Voltage in the primary is 230. Voltage on the secondary is 50. Number of turns on the primary is 200, and I'm trying to find the number of turns on the secondary. Now you remember from your maths, we need to clear these fractions, so we have to cross multiply. So 230 times Ns equals 200 times 50. So Ns, I want to get Ns on its own, I have to divide this side by 230. So I have to divide this side by 230. So Ns now becomes 200 times 50 divided by 230. So how many turns are required? So you do that with your calculator. 200 times 50 divided by 230. And that comes to 43.4 turns. So I'll call it 43 turns. So to get this transformer to work, I need to build it so that it's got 43 turns on the secondary coil. And that's how we work that one out. Okay. Right, so let's have another look. How are we getting on for time? Right. Get the book straight. If I now connect the transformer to a load, there's my transformer, 230 in, 50 volts out. I call that V primary, V secondary. If I now connect that to a load, there it is. Let's say that's 200 ohms is the load. Now current will start to flow around that circuit, and we know from Ohm's law that V over R equals I. So V over R equals I. So 50 divided by 200 gives you the current. Is 0.25 of an amp. If I now wanted to find out the current in the primary, because I know the current in the secondary, I can use these two here, I secondary over I primary. And don't forget, I secondary is always divided by I primary. So to do that, I can use the voltage of the primary and secondary. I'll get a more accurate answer if we use that. So I can now say VP over VS equals IS over IP. Substitute the figures. 230 divided by 50 equals 0.25 divided by I primary, which I'm trying to find. To clear the fractions, I cross multiply. 230 times IP equals 50 times 0.25. Just move the camera down a little bit. IP equals 50 times 0.25 divided by 230, and that comes to 50. Let's clear that. So 50 times 0.25 divided by 230, and I get 0.054 of an amp. Okay. So I'll probably need now to make a second clip in order to finish this particular problem off. So what I've found there are the turns required on the secondary to give me 50 volts, and I've now found the current flowing in the primary, which is I primary here and I secondary here, because I now know that particular current. So I've substituted it into the formula, and you'll notice here I've only used 2 parts of the formula there and 2 parts of the formula there. Okay, thank you.